Good day and welcome to this tutorial. In this tutorial, we will be dealing with pipeline corrosion modeling in Aspen Hysys. Now, corrosion is basically the degradation of materials, usually metals, right? And this is caused by the electrochemical reactions of these metals or materials with their environment. Now, these reactions can either occur naturally or can be aided by the presence of corrosive substances. Now, we have different types of corrosion, of which some include the uniform corrosion, pitting corrosion, galvanic corrosion, crevice corrosion, etc. Now, effects of corrosion in pipelines. Now, corrosion in pipelines can lead to the exposure of these pipelines, and this can lead to leaks and spills, right? By the time these pipeline surfaces have been damaged, it can lead to the leak of the substances that are being transported through these pipelines, right? And these leaks can also have negative impacts, right, on the environment, as some of these substances can be hazardous, right? And their exposure to the environment can lead to negative impacts on the environment, right? Also, this corrosion in pipes can also lead to the risk of explosions and fires, right? As some of those materials being transported can also be flammable, right? So you can have explosions or fires. So basically, corrosion of pipelines is actually not good and actually needs to be prevented or mitigated, right? Also, we have some of the measures that can be put in place to mitigate the corroding of pipelines, right? Some of them include the application of coatings and linings on the surfaces of pipes, right? These actually prevent the substances from coming in contact with the surfaces of the pipes, right? Then you have cathodic protection, you have material of construction. Basically, the material of construction implies the selection of the right materials required for the construction of the pipes, right? This would actually mitigate corrosion. Then you also have the use of corrosion inhibitors, right? So corrosion inhibitors can actually help to prevent or mitigate the rate at which pipes corrode, right? So we also have that for hydrocarbon mixtures, we have certain components that might be present in hydrocarbon mixtures that can actually lead to the corrosion of pipes, right? So some of those components include hydrogen sulfide, water, carbon dioxide, organic acids, chlorides, etc. Right? Also, for natural gas feeds, we have the common components that can lead to corrosion, which include carbon dioxide, hydrogen sulfide, and water, right? For carbon dioxide and water, they are usually regarded as acid gas, and they can actually be removed from natural gas mixtures using absorption processes, right? Gas absorption processes. While for water can be eliminated through dehydration processes. So I will just briefly show you some of the models in Hysys for both absorption and dehydration. So this is for absorption, right? So for absorption, you have the uh, absorber, right? This is the absorber column. You have the gas being fed into the absorber, and then you also have the substance that is used for the absorption of the acid gas, which in this case is DEA, which is an amine compound, right? An amine compound, DEA, right? So you can see the feed to the process. The feed to the process consists of, you have H2S present, you have CO2 present, and then you have H2O present, right? So these are the substances that can actually lead to corrosion, right? So and uh, for the absorption process technically removes CO2 and H2S, right? So this is the feed, and then you have the product. The product is sweet gas, which comes out from the top of the absorber, right? So from the top of the absorber, you have sweet gas, which does not contain carbon dioxide and hydrogen sulfide, right? So this particular process actually caters for the removal of these compounds from gas, right, or gas mixtures. In this model, you also have the uh, regeneration of the amine compound, right? So this column is for the regeneration, and then after regeneration, you have recycling back to the absorber, right? So the amine is reused, right? So basically, this is how the gas absorption model works, and we have videos for gas absorption in the channel, so you can check the channels playlist. You can check for gas absorption, right? There are three videos for gas absorption in case you need to model this process. Then we also have dehydration processes for water removal. So this is your dehydration process, which is also similar to the gas absorption process. The difference now is that in this case, you use or we make use of glycol compounds for the dehydration, right? So we make use of glycol compounds in this particular model. The egg was used for this, right? PEG was made use of in this particular model. And you also have the regeneration and recycling of the glycol compound, right? So this is your feed to the process G1, of which contains water. As you can see, H2O is 0.0229, right? 0.0229, right? And you can also check the we can check the product, which is the top, which is G3, and from G3 you can see that water is zero, right? So water has been successfully removed, right? You can see that water has been successfully removed from this particular process, right? So going back to our corrosion model, yes, going back to our corrosion model, we can do some analysis of or as regards corrosion using Aspen Hysys. So we'll still be making use of the feed data we used in the video for the hydrate formation, right? So we are making use of the same data, and basically this is what we modeled in that particular tutorial, and we'll be using this as a basis for this particular tutorial, right? So we'll be making use of this first pipe, which is pipe 100, right? So in pipe 100, under the flow assurance tab, you have CO2 corrosion, right? CO2 corrosion, right? So under CO2 corrosion, you have the corrosion models, and then you have do corrosion calculation, right? So you click on do corrosion calculation, it generates the plot and the respective tables, right? So for the corrosion models, you have three models present here. You have the Hysys NORSOC standard model. You have the WAD model of 95 and 91, right? So for this particular tutorial, I want to use the 95 model, right? Just for illustration, right? So I activate that, and then I activate the do corrosion calculation. So once I activate this do corrosion calculation, it generates a plot and also the table required, right? The results. So From the plot, we have a plot of corrosion rate against pipe length, right? Corrosion rate against pipe length. Under the corrosion rate, we have two plots. We have the corrosion rate and the scaled corrosion rate. So it plots both of them on the y-axis, right? And then this is your table of values, right? So these are different results that has been calculated by the software, and these results are based on the um, composition of the mixture, right? So the composition of the mixture consists of CO2, H2O, which are components that can lead to the formation of, or more like can lead to the corrosion of pipes, right? So even though H2S is not present, CO2 and H2O can actually lead to the corrosion of pipelines, right? So going back to the flow assurance, you have this table of values, and then from this table, the most important values we might be looking out for is the corrosion rate, right? The corrosion rate per year, right? So we have corrosion rate in millimeter per year, right? So this would help us determine the lifespan of the pipe, right? And I will be showing us how to actually do that. So we'll be making use of the pipe thickness and the corrosion rate, right, to determine the pipe lifespan, right? The pipe lifespan. So in order to do that, we'll be making use of the spreadsheet. So the spreadsheet in the software, we'll make use of the spreadsheet. But before we go there, let's do some adjustments. So I will go to options, and I would edit the unit of measure. So let's create a unit of measure. So we have a new user one. Okay, let's create one that is editable. Let's see, is this one editable? Yes, this is editable. So I just want to adjust the unit of time. So time is in seconds. I want to change it to years. So we'll determine the number of years that pipeline is going to last based on the corrosion rate, right? So we have adjusted the unit set, and it's already activated here. So we can continue with our model. So in order to do calculations within the software, we can make use of the spreadsheet. So we can make use of the spreadsheet to actually do calculations, right? So let's say I want to use two spreadsheets to do this calculation. So from our table, we can see from the table of pipe 100, you can see from the table that corrosion rate corrosion rate was specified for different sections of the pipe, right? So, but I want to determine corrosion rate of the entire pipe, right? So I will just basically take the average of this, right? And I'm taking the average because the sections are actually of equal length, right? So they are actually of equal length. Now, if the lengths of the different sections are different, then you have to do your calculations individually, right? You have to factor in the lengths of each of the sections, right? But in this case, since they are equal, we can just take an average of the corrosion rates, right? So basically, we'll be doing this to actually determine the corrosion rate of the entire pipe. So what I would do is I would select all these values, and I would actually send them to spreadsheet. So I will use spreadsheet tool to actually do this. So I click on B1 and I click OK, right? So I go back to spreadsheet 2, and you have them under spreadsheet, right? So just to recap what I did was I highlighted all the values. You can achieve that using shift. You click on the first value, you hold shift and you click on the last value, then you right click, right? You right click and you click on send to spreadsheet, right? So any of the spreadsheets you want to use, you send it to the spreadsheet, or you can create a new spreadsheet if you want, right? So basically that was what I did. So going back to spreadsheet 2, so I can take the average of this, which will now be my corrosion rate. So corrosion rate, we have taking average. So I will just type them individually. So typing them individually and dividing by 6, I press enter. So it gives me these values, right? So this is the corrosion rate per year, right? This is the corrosion rate per year based on our calculations, right? So we have our corrosion rate value, right? Now we can do further calculations. We can go over to calculate pipe thickness, right? So because formula for pipe lifespan is pipe thickness over corrosion rate, right? So we can now determine pipe thickness, right? So going for pipe thickness, let's see what we have. So when you open your spreadsheet, you click on spreadsheet, right? So we can determine pipe thickness by importing values for outer and inner diameter, right? Diameter. So we have inner diameter. So I'm just typing in the values. So I'm typing in the values. So we have outer diameter is let's check the value. We import it from the pipe 100. We have outer diameter. Let me see. Outer diameter. This is outer diameter. Then we also do the same for inner diameter as well, right? Still from pipe 100, you have inner diameter, which is inside diameter from here. So we have these values. Then we can calculate for pipe thickness. So for pipe thickness, we have formula for pipe thickness is B1, which is outer diameter minus inner diameter all over 2, right? So this is your value for pipe thickness, right? So we've been able to calculate pipe thickness, and you can confirm the diameter values from your pipe. So if you click on your pipe, you go to rating, you can see the values here for outer and inner diameter. So we've been able to calculate pipe thickness. We can import corrosion rate. So let's import corrosion rate. Corrosion rate. So for corrosion rate, we are also going to import variables. So we are importing from spreadsheet 2. So spreadsheet 2 B7 is our corrosion rate, which is the average of the corrosion values. So we have this as the corrosion rate. So we can calculate the pipe lifespan. So pipe lifespan, right? So pipe lifespan is equal to pipe thickness over corrosion rate, which is equal to B3 over B5, right? B3 over B5, of which we can actually find a unit for that. So we attach time to it because lifespan is with respect to time. So let's see. Okay, so we have time. Yes. So our pipe lifespan is 174.3 years, right? 174.3 years. And this is because the corrosion rate is very small, right? So the lower the corrosion rate, the higher the lifespan, right? The lower the corrosion rate, the higher the pipe lifespan. So if you want a shorter lifespan, then the corrosion rate will have to be higher, right? But like I said, this corrosion rate is based on the composition of the feed mixture, right? It's based on the composition of the feed mixture that we have flowing through the pipe, right? So basically, we've been able to determine the pipe lifespan of this particular pipe. Now, another thing I feel is important in corrosion is actually temperature. Temperature actually has an effect on corrosion as well, right? So apart from the presence of these components that lead to corrosion, temperature also has an effect on corrosion, right? So basically, these are some of the analysis that you can actually do with your software, right? These are the analysis you can do as regards corrosion with your software. You have your corrosion rate plot, you have your scaled corrosion rate plot as well, and then you have your tables which have all these data and your corrosion rate for each of the segments, right? So basically, with this, we have come to the end of this particular tutorial. If you have questions, kindly let me know in the comment section. Like this video, share with your friends, and then subscribe to this channel to get notifications on subsequent videos about process design. Thank you for joining me in this particular tutorial. Do have a good day.